Hi, everyone. I am Dr. Cardona, and I have a friend here, Ashley Welty Miller, who is a quality control analyst contracted through NOAA, the National Oceanographic and Atmospheric Administration. And she will be presenting on her work that directly ties to oceanography. Welcome, Ashley.
Thanks. I am gonna give everyone a little bit of information about my background, and then I will get into specifically what I do with NOAA. My undergrad was actually in meteorology, and I went to NC State, and then once I graduated, I ended up forecasting the weather for about a year. And I decided that I wanted to get more into oceanography, and I ended up applying for a job with NOAA at the Center for Operational Oceanographic Products and Services, which from here on out I will be calling co-ops. And so I was a contractor with them for a couple years. And that's kind of really where I learned most of my oceanography. And then I was a contractor with the National Weather Service for a year doing software testing. And then I came back to co-ops and eventually became a federal employee 6 years ago. So I have been in my position now, specifically for 6 years. So a little bit about co-ops and what it is. NOAA's Center for Operational Oceanographic Products and Services is the authoritative source for accurate, reliable, and timely tides, water levels, currents, and other oceanographic and meteorological information. Now, our services support safe and efficient maritime commerce and transportation. We help protect public health and safety, and we promote robust, resilient coastal communities. Co-ops maintains ocean observing infrastructure, which includes more than 200 permanent water level stations on the United States coasts and the Great Lakes. We've got an integrated system of real-time sensors concentrated in busy seaports, and we also have temporary meters that collect observations for tidal current predictions. And through these systems, we provide the nation with historic and real-time data, forecasts, predictions, and scientific analyses that protect life, the economy, and the environment on the coast. So as you can see in the image here, we've got, these are like our areas that we focus on, safe and efficient maritime commerce, coastal economies and infrastructure, mapping and charting support, and better public health information. So I'm going to talk a little bit about the mapping and charting. So our data is used for mapping and charting. So the water levels in our nation's Great Lakes, estuaries, and oceans are always changing. So engineers, surveyors, and shoreline mappers, pretty much anyone that's planning a project near or on the ocean or the Great Lakes, must have an accurate water level information and common reference points in order to measure the elevation relative to the water. So co-ops is responsible for producing and maintaining critical water level data and datums that provide a foundation for many coastal activities, which includes hydrographic surveys, nautical charting, shoreline mapping, navigation, marine boundary determinations, and dredging. Now, at the core is the National Water Level Observation Network, which we call NLON, and that's our entire network of all of our water level stations. It's a permanent observing system of more than 200 water level gauges throughout the United States and its territories. And so we've got stations in Puerto Rico, we've got them in the Pacific Islands and things like that, like Guam. So we've got a good coverage. Let's see. And the NLON is the source for accurate real-time and historical water levels for the government, the commercial navigation sector, and recreational users. Water level data collected from NLON must also meet rigorous scientific standards because it's used to calculate tide and water level datums, which is the official vertical reference framework for our nation's coast. And a tidal or water level datum is a reference plane in the ocean or the Great Lakes, and it's used as a starting point to express local water heights and depths. The oceanographers within co-ops produce and maintain the nation's official tide and water level datums, and it's a very highly complex and challenging process. And these products benefit everything from the NOAA nautical charts, as I mentioned, to U.S. Army Corps of Engineers infrastructure projects, to local marsh restoration, and they serve as the legal basis for marine boundary and shoreline determination. So if you think about that, like that's a lot of information that is being used. Like there's so many different applications for this data, and I'm gonna get into the things that I work on. There's even more products that are created within my office, but we would be here for hours if I talked about them. So I'm just going to focus on the things that I specifically do. So as far as water levels, that is my main job title or duty. For the first half of the month, each month, I work on water level data, and I'm on our data processing team, which is in the Oceanographic division of co-ops. And our mission is to provide quality assured, verified tide, water level, current, and other coastal oceanographic data and operational oceanographic products to support that safe and efficient navigation and coastal hazards preparedness and response. So this translates specifically to the water levels, and I perform operational data quality control and quality assurance, and I tabulate data and compute and generate operational oceanographic products from the time series from each of these water level stations. And I mentioned we've got over 200 all along the coast, and I'm in charge, or I'm responsible for, I only process about 15 of them, but I verify the water levels. So we've got people who go and process this data, and then we have someone who has to verify it. So it's got like a double check of the data. And I'll show you the application that we use to do that in a few minutes. But the products consist of 6-minute data, hourly heights, highs and lows, and monthly means. And I'm gonna go ahead and show you what I use to do that. So we've got this program that we call WallE, and it's pretty much how we take all of our data, our water level data. So I usually will have to go in and plot some data. So let's just pick a random station. We can do Baltimore. The data that we work with, and when I talk about highs and lows, like, all right, so this right here is 6-minute water level data, and then this other thing I'm plotting is highs and lows, and we have to go in and actually pick the highs and lows, and that information is used for a million other products. But like you can see here, this is the month of February, and this is all the water levels and the high tides and the low tides in Baltimore. But there's a lot more that goes into this, but I just wanted to show you, like, this is one of the things that I'm specifically working with each month. And so another part of that, or that I work with, is currents. So obviously we've got the water levels, but we've also got currents, and the currents, oh, I actually realized I forgot to go over tide predictions. So the data processing team quality assures and processes and generates all these products from the water level data. And we also do it for a bunch of different partners. So we do projects with vertical datum transformation projects. We've got the National Weather Service Tsunami Program. We work with USGS, the Army Corps of Engineers, and the National Estuarine Research Reserve System. So we are constantly working on lots of different projects and getting data from new stations. But the reason that we do so many of these projects is because we are trying to make tide predictions. And obviously tide predictions are extremely important for maritime commerce and lots of different things. But when we take this data, that we have harmonic constituents that are analyzed, and each one plays into a mathematical expression for the tide producing force and in corresponding formulas for the tide or the tidal current. And so each of these constituents represents a periodic change or variation in the relative positions of the Earth, Moon, and Sun. And when they're all calculated together, you can get the predictions for tides at a specific location. And currently within co-ops, these predictions can be gathered at over 3,000 different locations along the United States coast due to the fact that we have a lot of historical data from so many projects. And, you know, those include all those partners that we work with. So, but yeah, you know, talking about them needing that information for maritime commerce, you know, if it's high tide, they might not be able to get in or get under a bridge. So like the Chesapeake Bay Bridge, we have a sensor called an air gap sensor, and that actually measures the space between the actual air gap from the bridge to the water surface. And if it's high tide, a ship might not be able to make it through there. And we actually had a few years ago, it was a really big deal because this massive container ship was coming into the harbor, and it literally went under the bridge with about a foot to spare. So I can't even imagine like being on the ship and like being right at the tip top of it. And you know, but that's like a real life application of how this data is being used. So anyway, to go back into currents, so we've got the water levels, and we also do currents in the ocean. And so NOAA periodically will conduct current surveys in areas around the nation to ensure the accuracy of the tidal current predictions. And we also offer real-time current information as a part of our physical oceanographic real-time systems, and we call those ports. But commercial and recreational mariners depend on this information also for safe navigation. Because if you think about it, you know, they'll know how fast they can get somewhere if the currents are even stronger or going against them and things like that. So my team does quality control on this data as well, and we do monthly analyses on the real-time current meter stations, and to help create the products, but it's also to help reveal communication problems and instrumentation failures. And we check for changes in the current patterns to be reflected on our website. And about 1 to 2 individual current surveys a year are being conducted within co-ops, with 20 to 60 current meter stations being deployed. And we process anywhere from 30 to 100 days of data for each station. And as I mentioned, the purpose is to update the NOAA tidal current predictions. And most recently, we had a deployment in Cape Fear, North Carolina, and then the Columbia River in Oregon and Washington. So the water levels and currents are pretty much the bread and butter of our work within co-ops. And then based on that data, we are able to make a ton of different products from that. So I'm going to get into some of the other products that we create from that data and show you a few examples. So quick look in coastal inundation dashboard. I think I'm just going to click on the link to show you all instead. So this right here is the coastal inundation dashboard, and it provides real-time water levels and 48-hour forecasts of water levels and historic flooding information at a majority of coastal water level stations operated by co-ops. And this product features both a map-based view where users can see which stations across the US may be flooding. And you can see that right here, these 2 stations you can see are kind of blinking, and then over here. And usually those start blinking when they might be in a flood stage. So it's really cool to visually be able to see that. Emergency managers and other coastal decision makers can use this information to understand and prepare for the impacts of coastal flooding. And the coastal planning community can use this to get a better understanding of past peak water level events and the increased frequency of days when flooding is possible as sea levels change. So I'm going to zoom into one of these stations just to show you what happens if we click on one. So all of these flooding thresholds are from the National Weather Service, and every single one of these stations has the thresholds in here for minor flooding, moderate flooding, and major flooding. So it's a really cool way to be able to just look at the data and know immediately if your area is probably experiencing flooding. And whenever we have hurricanes or tropical storms, like, it's really, really neat to see on here, because this product actually is enhanced to make a quick look posting. So I'm going to talk about that really quickly. So when the National Weather Service issues a tropical storm or hurricane watch or warning for the US, co-ops will begin to monitor the water levels in the path of the storm. And so this will be available as a customized view on the Coastal Inundation dashboard map that will show the latest tropical cyclone forecast, track, and intensity information, the active storm surge watches and warnings, and then coastal flood watches, warnings, or advisories that are issued by the National Weather Service. We also have a summary of coastal water level conditions that gets updated 3 times a day. And so because of these storms, it's obviously going to increase or elevate water levels. And this is a really cool way to be able to see those water levels and how it directly is affecting the stations. So whenever, if there was a storm coming up here, you would see the track of the storm. And then it's just really cool to actually look at these graphs and be able to see how elevated the water levels are. So I was thinking about waiting to share this one thing that I have made, because it's kind of, it's GIS related, but I might just show it now. You just see something. I'm trying to think where my link is to it. Sorry about this, guys. 1 second. I have the link in here. Okay. So this is it's called a story map. I'm not sure if any of you are familiar with GIS, which is mapping software, and Esri is the company who's kind of got a monopoly on all of it. But this is a story map that I made with some of their online, the ArcGIS Online application. But anyway, so it's pretty much a story about the hurricane season for 2020, but it's really neat because you can pull the maps into it. So I was able to make a map showing all of the hurricanes and tropical storms of the season, and I symbolized them based on their intensity. And then if you scroll through, we've got Hurricane Hannah here that we highlight, and the maps show the maximum water levels based on that time period for the storm. And there's one that I really wanted to show you because it's really interesting, because whenever we've got storms, we're always worried about the flooding. And one of them, I think it was Hurricane Laura maybe, or Sally. Because of the orientation of the storm, it ended up taking the water out of Mobile Bay. And if you zoom in here, and we've got this graph here, I'm sure it's kind of hard to see for you all, but this is all the water levels, the water being sucked out of the bay there. So it's really neat to just kind of visually see what was happening instead of the water levels obviously flooding, because just by the time the storm was over here and the winds are coming from the north/northeast, it just pushed all the water out of the bay. So it's really, really neat to see what these storms actually can do to the water levels. Let's go back to that. So something else that I work on is sea level trends. And so as I've talked about, we've got a ton of different water level stations along the coast. We have been measuring sea levels for over 150 years with tide stations that are part, all part of that NLON that I talked about, the National Water Level Observation Network. And changes in relative sea level, either a rise or fall, have been computed at 142 long-term water level stations. And that's using a minimum span of 30 years of observations at each location. So these measurements have been averaged by month, which removes the effect of higher frequency phenomena in order to compute an accurate linear sea level trend. And the trend analysis has also been extended to 240 global tide stations that use data from the Permanent Service for mean sea level. And that work is funded in a partnership with the with NOAA's OAR Climate Observation Division. So, sea level trends are really important. It's a big deal every year. There are a lot of different places they're increasing. And so I'm going to show you all a map that I made showing those sea level trends. This is more of the GIS that I'm talking about. So even though we're talking about oceanography here, like GIS plays a massive part in it because we are able to, as I mentioned, visually represent that data and see it on a map instead of just having a bunch of numbers in a spreadsheet or something. So yeah, but you can see here almost every single one of these stations, the locations, the sea level trends are increasing. There's only a few places where they're decreasing, and that is pretty much in Alaska, and that's really just because of subsidence. The actual water levels are still actually increasing. But this is a really cool project because I'm not sure if any of you are interested in any kind of coding, but we used Python coding to create these visualizations of the sea levels changing throughout the years. And so it tells the year that the data is from, and then you can see it building on itself as those sea level trends increase or decrease depending on, what location we're at. So yeah, sea level trends are something that I work with a lot. And then another product that we deal with is extreme water levels. And so extremely high or low water levels at coastal locations are an important public concern and factor in coastal hazard assessment, navigational safety, and ecosystem management. And so the exceedance probability, which is the likelihood that water levels will exceed a given elevation, is based on a statistical analysis of historic values. And this product provides annual and monthly exceedance probability levels for co-ops water level stations, once again, with at least 30 years of data. And when used in conjunction with real-time station data, the exceedance probability levels can be used to evaluate current conditions and determine whether a rare event is occurring. Something else that we are doing is we do a lot of work with high tide flooding, and there's a report that we put out every year in June or July, and it's literally the annual high tide flooding report. And I'm not sure if you all are familiar with it, but I'm sure you've seen it. It's often referred to as nuisance or sunny day flooding, and it's increasingly common due to years of the relative sea level increases. And it occurs when the tides reach anywhere from 1.75 to 2 feet above the daily average high tide and start spilling into streets or bubbling up into storm drains. And if you've been in downtown Annapolis before, I'm sure you've seen that whole area down there get flooded. It happens a lot, and it's happening a lot more now. And that's part of the high tide flooding that I'm talking about here. We take all of the historical data and we make projections out to the future to see how more frequently that's going to happen. And then that information is being used for obviously infrastructure and city planning, because if there's going to be high tide flooding 50 days a year, you know, why would you want to put a business there or something like that? And so as sea levels continue to rise, the damaging floods that decades ago happened only during a storm now happen more regularly. And as I mentioned, each year NOAA documents the changes in high tide flooding patterns from the previous year at 98 of our tide gauges along the US coast, and we provide a flooding outlook for these locations. And so I'm going to click on that right now. So this is the high tide flooding page of our website, but it's really cool because this is also another GIS map that we have here. But you can see the bar here goes from 0 to 5 and to 160 plus. So at locations here, like in Maryland and things like that, or Virginia, you know, how many flood days a year? 10 to 16. If we look at 2030, we're going to have 15 to 25. In 2050, this is a large range. They're not always this large, but 45 to 160. So we can also change the map to display the data also, and you can see as we move through time just how much more it's increasing. And if you're going to be down in Louisiana, it's probably not going to be a very good time for you, because 145 is the minimum, and that's not half a year, but it's getting there. So it's our analyses are what give us this information, and like I said, it's used for planning and infrastructure, and it's super important. So the last thing that I was going to go over that I work with, I mean, I've already mentioned that I do GIS, but GIS is becoming extremely important within NOAA, all across NOAA, and it's been part of the NOAA priorities for many years now. And one of those priorities are to increase sustainable economic contributions of U.S. fisheries and oceans, which includes developing resilient coastal communities and economies. And the GIS work that Co-ops is doing directly relates to that goal. It's also part of our strategic plan, which is to advance and integrate a full spectrum of inundation products with extended outlook and spatial coverage for storm surge, high tide flooding, and sea level trends. And as you can see, I've just talked about all of those. And I lead our GIS team at Co-ops. And so I've been trying to really infuse GIS into everyone's daily workflows, or just to get more people familiar with it. And I'm just going to go over a couple things that we have created most recently that I think are really interesting. This right here is another story map that we created with Esri and Old Dominion University. And it's pretty much a story talking about coastal flooding and what it is, what the data are telling us, and how it's affecting coastal communities. And so I can send this out at the end so you have the links to these if you're interested. But it's really neat because it's just another way for us to pull in these maps and be able to actually see the information. Here's another example of a map showing, this is one showing all of the sea level trends around the entire world versus just the United States, which is what I had shown you earlier. But it's really cool. This shows it shows scenarios of flooding, like what 1 foot of water increases in water levels would do, and which parts would be underwater, as you can see right there. But I would highly suggest scrolling through this and reading it because it's very, very informative. And I feel like anyone in an oceanography field would benefit from reading this. We had our subject matter experts go through and do all of the verbiage for everything. So it's very, very informative. But these are all GIS maps showing flooding and different levels of flooding. And then another project that we are working on is our contaminated water and dive safety tool. Sorry. And this project was a labor of love, and I honestly didn't even do a lot of the work on it because I have so many other things that I work on, but my team did this. And so what this is a, let's see. Here we go. So there's a ton of information in here. We've got stuff for EPA information. We've got different things for like harmful algal blooms in here. But this is all color coded by the relative safety to go diving at these locations. So these are all of our water level stations, and based on feedback from our field operations team, they go out and actually inspect the stations and do the cleanings and make sure that everything is stable and blah, blah, blah. But they have to go to do that. They have to dive. And they really wanted to have a tool that would help them be able to better understand if it's safe for them to dive in that area. And also for planning purposes, we've got information in here for hospitals with hyperbaric chambers and other things like that. And so this is one of our biggest / newest projects that we've been doing. And it's apparently it's very popular, and like a lot of different offices within NOAA are starting to use it too. So we're really excited about that as well. I think that was Christina. That's pretty much all I had planned on going over for today. I know it's not a full hour, but I don't know if there's anything that like maybe you want me to talk about or go over again or anything, but if not, I can just open it up for questions.
That's fine. You can open it up for student questions at this time.
Okay. Does anyone have any questions?
Are there any questions at all? You can either type or speak up at this time.
I don't have any questions, but thank you for the presentation and sharing the information.
Thanks, it's my pleasure.
Well, it seems that one student says, I don't have any question, but I was just curious. Do you have something specifically? Nope. Okay, so it looks like no questions.
I have a question.
Oh, go ahead, Alan.
Aside from doing work here in the United States, do you guys collaborate with, I guess, other countries, other governments, stuff like that?
So I know that we're working on a project right now with Argentina, but it's not too often. I mean, it's definitely like we are funded by the US government, so we kind of only can work on things for the United States government. But there's plenty of opportunities for collaboration with other countries and like working on projects together. So yeah, like I said, I mean, we are working on something right now with Argentina.
Looks like you have a question on here. Can you explain more about how the data for flooding is tabulated? Is it based on predictions on what will happen or just what might happen if the ocean levels rise?
So it's kind of a combination. We've got the sea level trends, which are a constant. We know that that's going to happen. And then we also take that information about like for high tide flooding days. And so there are, you know, maybe 10 years ago, it was only happening this many times, and now it's happening more. And based on all those trends, we can further project how many days we'll have high tide flooding, stuff like that. There's the sea level trends are a separate kind of, all these are just based on algorithms. There's a bunch of different like equations that are literally being run on the data, and but there's a lot of different factors that play into it.
Thank you. Does anyone else have any questions? Just one here. It says, I thought that was very interesting. I'm not familiar with a lot of the terminology, but I have a better understanding on topics you discussed. That was more of a thank you. Well, I appreciate your time and your presentation. It's very applicable to a lot of the courses that we have here at CTVC, including my oceanography class that I see a couple of students are here for. So thank you again. And
Thanks.
I will stop the recording at this time.
Okay.